Hello my dear class 10 students, this is your Ekta ma'am here. Here are all the important chemical reactions. Actually it has all the reactions that are given in your CBSE class 10th syllabus. Yes my dear kids, if you do these reactions, you do not need to do any other reaction. So let's begin. First one is burning of magnesium ribbon. When you burn magnesium ribbon, what do you get? We get magnesium oxide, right? What is the color of magnesium oxide? It is white in color. It is white in color. Then conversion of quicklime into slaked lime. When you take quicklime and you add water to it, we get slaked lime. This is slaked lime. The other name that we use is lime water. It is lime water. We also call it lime water. Then carbon dioxide with lime water. This lime water further reacts with carbon dioxide and we get this milky calcium carbonate. Milky calcium carbonate. Clear? Now if you heat this calcium carbonate, what do we get? Calcium oxide and carbon dioxide. If you heat it, we get calcium oxide and carbon dioxide. One more thing is there, if calcium carbonate is there and if you pass carbon dioxide gas through it, that's what called prolonged passage of carbon dioxide. What do we get? We get, and there is water also obviously, we get calcium hydrogen carbonate. Calcium hydrogen carbonate. Now this is water soluble. This is water soluble. So on prolonged passage, what happens? On prolonged passage of carbon dioxide, what happens? That initially the milky calcium carbonate gets converted into water soluble, which is not milky at all, which is clear. Calcium hydrogen carbonate or calcium bicarbonate. Next is lead nitrate. Decomposition of lead nitrate gives lead oxide, which is yellow in color, nitrogen dioxide, which is brown in color, and oxygen gas. Now what happens when you heat iron sulfate? When you heat iron sulfate, it has around 7 water of crystallization. First of all, it is green in color. If you heat it, we get iron sulfate and water. Okay, water of crystallization are lost. This is white in color. Now if you further heat iron sulfate, what do you get? You get iron oxide and sulfur oxide and sulfur dioxide and sulfur trioxide. These are the oxides of sulfur and this is iron oxide. Iron oxide is brown in color, okay, and these have a rotten egg smell. The oxides of sulfur have a rotten egg smell. Next is silver chloride and silver bromide. So when you heat, firstly silver chloride is white in color, silver bromide is yellow in color, and when you do decomposition in sunlight, we have 3 type of decomposition, right? Thermal decomposition, electrolytic decomposition, and photolytic decomposition. Thermal means using heat, electrolytic means using electricity, and photolytic means using sunlight. So using sunlight you do the decomposition, we get silver and chlorine. Now silver is grey in color, this is grey, right? And chlorine is yellow. It is yellowish. Next is electrolysis of water. When we do electrolysis of water, we get hydrogen and oxygen. Now at cathode we get hydrogen. H is there, so you can remember cathode we get hydrogen, and at anode we get oxygen. Next is combination reaction. Here are some combination reaction. When carbon combine with oxygen, we get carbon dioxide. When hydrogen and oxygen combine, we get water molecule. Next is displacement reactions. Iron combines with copper sulfate. Now iron is brown in color actually, and copper sulfate is blue in color. When the reaction happens, we get iron sulfate which is green in color, and copper which is reddish brown in color. Okay, so sometimes you get a brown deposition on the iron plate, okay, on the iron plate. Next is double displacement reaction. Sodium sulfate reacts with barium chloride, we get a white PPT of barium sulfate and sodium chloride. This is the insoluble salt. This is the insoluble salt. Next is reaction of potassium iodide and lead chloride. Potassium iodide reacts with lead chloride, which is white in color, and we get lead iodide. We get lead iodide, which is yellow in color. Okay, lead iodide and potassium chloride. Again, it is the insoluble salt, it is the precipitate. Now these reactions are double displacement reactions, right? There is exchange of ions between the reactants. Next is potassium bromide reaction with barium iodide. When potassium bromide reacts with barium iodide, we get barium bromide and potassium iodide, right? Again, double displacement reaction. Redox reaction, oxidation means addition of oxygen and reduction means removal of oxygen, or you can say addition of hydrogen. Okay, whenever oxygen is getting added, copper, which is brown in color, if you add oxygen, we get copper oxide. Now copper oxide is black in color. Copper oxide is black in color. If you pass hydrogen gas through copper oxide, if you pass hydrogen gas through copper oxide, we get copper and water. Now copper, again, it is brown in color, reddish brown. Okay, next is acids, reaction of acids with metal carbonates or metal bicarbonates. When acids react with metal carbonate or metal bicarbonate, both, we get a salt plus carbon dioxide gas is evolved and water. Carbon dioxide gas is evolved. Next is acids with metal. When acid reacts with metal, we always get salt plus hydrogen gas. Okay, now these acids are hydrochloric acid and sulfuric acid. Then there is other acid, right? Nitric acid. With nitric acid, the reaction is a little different. Nitric acid with all the metals except magnesium and manganese, except these two metals, it does not evolve hydrogen gas. It makes salt plus water. It gives salt plus water. With all the other, with magnesium and manganese, it evolve hydrogen gas. It evolve hydrogen gas. Okay. Next reaction is metals with bases. When metals react with base, we get a salt and hydrogen gas is evolved. The metal that we are discussing here are amphoteric. What do you mean by amphoteric, ma'am? Amphoteric means they react with both acids and bases. So when zinc reacts with base, we get sodium zincate, which is an important salt, and hydrogen gas is evolved. Next, when aluminum, which is also, we have zinc, aluminum and lead. These three are amphoteric metals. So when aluminum reacts with sodium hydroxide with the base, we also get a salt and hydrogen gas is evolved. Salt is sodium aluminate. Next reaction is acids with bases, which is neutralization. There are three types of salts: neutral salt, acidic salt, basic salt, right? So when a strong acid, strong base reacts, we get a neutral salt and water molecule, right? Next is strong acid, weak base, we get an acidic salt, right? Because the acid is strong. Then weak acid and strong base, because the base is strong, we get a basic salt. This is a basic salt. Next is chlor-alkali process. Very, very important, my dear kids, for this exam point of view. Star market. Chlor-alkali process means when you take a brine, which is aqueous solution of sodium chloride, aqueous salt solution, aqueous solution of sodium chloride, and pass electricity through it, we get sodium hydroxide plus hydrogen gas and chlorine gas. Now chlorine gas is evolved at anode, hydrogen gas is evolved at cathode. Again, simply remember, cathode has hydrogen, hydrogen also has hydrogen, H, right? Then you have sodium hydroxide, which is also evolved at near the cathode. Next is formation of bleaching powder. Remember, this is the formula of bleaching powder. Do not confuse it, okay? Always use this formula because this is given in the NCERT, and obviously we need to follow the NCERT verbatim. Now calcium, this is slaked lime. This is slaked lime. When you pass chlorine gas through slaked lime, what do we get? We get calcium oxychloride. This is bleaching powder, or calcium hypochlorite also, plus water. Okay. Now, how do you form baking soda and washing soda? These are formed by a process called solvay process. These three steps are there in the solvay process. First steps include, you have a brine, which is aqueous solution of sodium chloride, and you put ammonia in that solution and pass carbon dioxide gas through it. What do you get? You get baking soda, sodium hydrogen carbonate, which is baking soda, plus NH4Cl, which is a salt again. Now, if you heat this baking soda, we get sodium carbonate. We get sodium carbonate plus hydrogen plus water plus carbon dioxide, right? Now, if this sodium carbonate, if we add 10 water crystallization to sodium carbonate, we get washing soda, which is Na2CO3.10H2. This is washing soda. It is very important. Now, other thing is there, we have baking powder, right? What is baking powder? It is a mixture of baking soda and any edible acid. So baking soda plus any edible acid. Baking soda plus edible acid. That is what? That is baking powder. Baking powder. Next is formation of plaster of Paris. If you have gypsum and you heat it around 100 degrees Celsius, it loses 1.5 water of crystallization and we get plaster of Paris, right? Next is what happens if you heat gypsum above 100 degrees Celsius, greater than 373 Kelvin, it will lose all its water molecule and gets converted into CaSO4, calcium sulfate, which is dead burnt plaster. Now how do metals react with oxygen? When metals react with oxygen, we get metal oxide. Now these metal oxide, if you combine them with water, we get a base. That's why metal oxides are basic in nature. Metal oxides are basic in nature. Next is non-metals with oxygen. Again, non-metal reacts with oxygen, form non-metal oxide. Now these non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. Why? Because if you combine them with water, you get an acid. Next is how do metals react with water? So there are certain categories. They either react with hot water, they either react with cold water, hot water, water vapors, and there are some metals like lead, copper, silver, gold, platinum, copper also, right? They do not react with hot water, cold water or water vapors, right? So let's discuss the first one, which is cold water. Sodium reacts with water, we get sodium hydroxide, right? And hydrogen gas is evolved. It reacts vigorously with water. This hydrogen gas catches fire as soon as it is released. Next is hot water. Some metals react with hot water, right? And for example, magnesium, and form magnesium hydroxide, and hydrogen gas is evolved. Again, this is not gonna catch fire. Next is steam. Some metals react with water, steam, water vapors, aluminum and iron. They form oxides. Instead of hydroxides, they form oxides. Why? Because at higher temperature, oxides are much more stable than hydroxides. Next is reaction of amphoteric oxide with metals. When amphoteric oxide, aluminum oxide is amphoteric. Okay, when it reacts with an acid or a base or an acid, what happens? We get a salt plus water. Next is roasting. Roasting is heating a metal ore, sulfide ore basically. Heating a sulfide ore in presence of excess air. You heat it in presence of excess air. It gets converted into its corresponding oxide, and again sulfur dioxide gas is released. Next is calcination. Calcination means heating any carbonate ore. Actually, we are heating carbonate ore in absence of oxygen. Heating any carbonate ore in absence of oxygen is called calcination, and again we get metal oxide plus carbon dioxide gas is released. Thermite reaction, very important. Aluminum reacts with iron oxide. We get aluminum oxide and iron. Now aluminum oxide is okay, but there's a lot of heat released, and due to this heat, it is highly exothermic, right? And due to this heat, iron gets melted. Now this melted iron is used to join the broken railway tracks. Next is combustion. Whenever you are combusting anything, you are adding oxygen, you are giving unlimited supply of oxygen, and in turn we are getting heat and light. So whenever combustion is there, you see some heat, you feel some heat, and there is light. So this is the combustion of hydrocarbon. Which hydrocarbon is this? This is ethene. Right? You get carbon dioxide, water plus heat and light. Next, oxidation of alcohol. When you oxidize alcohol, you use either alkaline camphor or acidified K2Cr2O7. These two are good oxidizing agents. What are oxidizing agents? Oxidizing agents are those species which add oxygen. Okay. When you do oxidation of ethanol, we get ethanoic acid. One more oxygen is added. Next is addition reaction. One of the most common one is hydrogenation. In hydrogenation, what do? We take an alkene, or you can say unsaturated compound. These double bonded and triple bonded carbon double bond, carbon triple bond, these all comes under unsaturated compound. So when you have an unsaturated compound and you pass hydrogen gas through it in presence of a catalyst, we get a saturated compound. Saturated compound means having only single bond, carbon single bond, carbon hydrogen single bond, right? This is addition reaction. The name of this reaction is hydrogenation. It is a type of addition reaction. Next is substitution reaction. Substitution reaction is shown by saturated compounds which have all single bonds. So what happens? One atom comes and substitute one of the atoms already present in the compound, and that's how we get our new compound. Okay, substitution. I'm already standing here. If some other teacher came and replaces me, that is called substitution, right? But in place of me, there is two more teachers, that is called addition, right? I hope you get it now. Next reaction actually. Reaction of ethanol with sodium metal. When ethanol reacts with sodium metal, we get sodium ethoxide. This is sodium ethoxide. And hydrogen gas is evolved. Again, this is a test for it can be used as a test to know if ethanol is there or not. If ethanol is there, hydrogen gas will be evolved. Next is dehydration of ethanol. Dehydration means when you put hot concentrated sulfuric acid and heat the solution around 443 Kelvin, what happens? Ethanol gets converted into ethene. Dehydration means removal of one water molecule, and there is a removal of one water molecule. Next is reaction of ethanoic acid with sodium carbonate, metal carbonate, bicarbonate. What happens when you treat it with metal carbonate, bicarbonate, anything, ethanoic acid? It makes a salt first of all. This is a salt, sodium salt of carboxylic acid, and carbon dioxide gas is released with brisk effervescence. Again, effervescence means in a solution when there are gaseous bubbles, they are trying to bubble out. You know, they are trying to come out of the solution. So suppose that this is the solution, right, and we have these bubbles and they are trying to bubbling of these solutions, right, they are trying to come out of the solution. That is called effervescence. It could happen with any other gas also, hydrogen also, carbon dioxide also. Okay, now here it is a test that can be used to distinguish between ethanol and ethanoic acid. So because ethanoic acid reacts with sodium carbonate, sodium bicarbonate, right, but ethanol does not react with sodium carbonate or sodium bicarbonate, thus it can be used as a test to distinguish between ethanol and ethanoic acid, right. Next is esterification, very important. Mark these two. These will come in your exams, my dear kids. Esterification means when an alcohol and acid reacts in acidic medium. When an alcohol and an acid reacts in acidic medium, we get an ester. And what is saponification? When that same ester reacts with, when ester reacts with base, and we get sodium salt of carboxylic acid and alcohol back. Okay, so when ester reacts with a base, we get sodium salt of carboxylic acid, we get acid and alcohol. This is saponification. Normally this is salt, this is soap. What are soaps, right? They are sodium or potassium salt of long chain carboxylic acid. So if instead of this one you have a long chain carboxylic acid, C16, C12, C17 something, so it will be soap then. Okay, next is reaction of copper with carbon dioxide. This is important. See, copper reacts with carbon. Firstly, copper reacts with oxygen and it forms copper oxide, which is black in color. Now this copper oxide combines with the atmospheric carbon dioxide and we get copper carbonate, which is green in color. Next is photosynthesis and respiration. Photosynthesis is what happens in our plants, right? They prepare their food by photosynthesis. So carbon dioxide they take from the environment, and water they take from the roots, and then they have sunlight, right? It is an endothermic process. So they carbon dioxide, water in presence of sunlight. Chlorophyll is also there. We get glucose plus oxygen gases released. That is photosynthesis, endothermic process. Respiration is done by us humans. We have glucose, we eat food, carbohydrates, everything, and then we inhale oxygen. Oxygen is used for respiration. And in the mitochondria, what happens? The reaction happens actually. We get carbon dioxide gas is released, water plus energy is released. This energy is what making us stand, what making me talk. You listen and you trying to understand. That is the energy. That all is coming from your respiration, my dear kids. Okay, and that was all. Okay, I hope you enjoyed it, and give this video a thumbs up, and do not worry if you do all these reactions, you do not have to worry about any other reaction. All the best.